All right, guys, are there any questions over any of the assignments thus far? Question over anything we've done so far? From? That is. Yes. Okay. Because you didn't show up?
Well, I called cheerleaders and I walked in.
Were you here at the bell? Were you here at the bell?
I have no idea.
Because they announced the cheerleaders after the bell. Yep. So let's look at this here. So find the measure of the numbered angles in rhombus DEFG. So since it's a rhombus, we know that all the angles where the diagonals cross are 90 degrees. So the measure of angle 1 is 9 degrees. We also know that the diagonals bisect the angles. They cut them in half. So if the top, this angle is 48, we know that angle 4 has to be 48. So we know the measure of angle 4 is equal to 48 degrees. Yes. Now, since we know this is 48, this is 90, these three angles have to add up to be 180. So we can say 48 plus 90 plus x is equal to 180. Well, 48 plus 90 is 138. And if we subtract 138 from both sides, we get that x is equal to 2, 4. So the measure of angle 2, yes. 2 and 3 are both 42, 4 and 5 are both 48, and number 1 is 90. Any other questions on 14 before we look at 28? So 28. We are given the two lengths of the diagonals, and we know that the diagonals in a rectangle are equal. So we need to solve for the value of x and then plug it back in. So the first thing we can do is, make sure, that's minus 6. 36x minus 6, 16. Yep. So the first thing we can do here is add 6 to both sides. 16x plus 2, 36x, yep. It's going to give us 8. Or 16x plus 8 is equal to 36x. Yep. Next we can do is subtract 16x from both sides. Yep. And if we subtract 16x from both sides, we have 8 is equal to 20x. Then we're going to divide both sides by 20, telling us x is equal to, because 4 will go into both of them, 2 fifths. 36x minus 6, 16x plus 2. Now we can plug it back in. 16 times 2 fifths plus 2. go. 16 times 2/5 is going to be divided by 5, 6.4. And 6.4 plus 2 is 8.4. Any other questions on 7.4? 7.42.
Is that actually what you can do? You can times it by the...
Yeah. Because 16 times 2 is 32. Yep. Yeah, we can plug it back in as 2/5. Either way works. Any other questions on this here? So what we're looking at today are trapezoids. Thank you. Trapezoids. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So if we have a four-sided figure with one pair of parallel sides, it's called a trapezoid. Now the two sides that are parallel are called the bases. So the set of sides that are parallel in a trapezoid are the bases. The other two sides are the legs. So every trapezoid will have two legs and two bases. Now we call the angles base angles because they're attached to the bases of the trapezoid. Now we call one an isosceles trapezoid if the two legs are congruent. If the two legs are congruent, then it's going to be an isosceles trapezoid. Any questions on this so far? All right, guys, heads up. Now, our first theorem, isosceles trapezoid base angle theorem. So if it's an isosceles trapezoid, then each pair of base angles is congruent. So the top two base angles would be congruent, and the bottom two base angles are going to be congruent. And that's only true if it's an isosceles trapezoid. If a trapezoid has a base or pair of congruent base angles, then it's going to be isosceles. So one implies the other. If it's isosceles, then the base angles are congruent. If the base angles are congruent, then it's going to be isosceles. Any questions over these first two theorems? 17.16, the other theorem that we have here, is the isosceles trapezoid diagonal theorem. A trapezoid is isosceles if and only if its diagonals are congruent. So if the diagonals are congruent, then it's isosceles. Any questions over these three theorems here? So let's look at our first example. The stone right here. Stone above the arch in the diagram is an isosceles trapezoid. We have the two legs congruent. We want to find the measure of angle K, M, and J. So if it's isosceles, we know the base angles are congruent. So since the measure of angle L is 85, we know that the measure of angle K has to be what? 85 degrees, because the base angles are going to be congruent. What do we know about the measures of angle M and J? M and J are going to be congruent. They're going to be the same. So, and what do we know about a four-sided figure? The sum of the interior angles is going to be not 180, 360. Guys. Thank you. So what we can do is add these together and set it equal to 360. Mm-hmm. 85 plus 85 is 170. X plus X is equal to 360. The next thing we can do is to get 2x by itself by subtracting 170 from both sides, which these will cancel out, leaving us with 2x. 0 by 0, 0. 2, 1, 9, 1. So we have that 2x is equal to 190. And from here we can divide by 2. So x is equal to yeah, 95. Because 2x divided by 2 is x. 19 divided by 2 would be 9 because 18 and 5. So the measure of angle M is, and the measure of angle J is 95. Because the bottom two angles, J and M, are going to be congruent. Questions on this so far? What do we notice about the measure of angle K and J? What do they do? Add up to 180, yes? Our consecutive interior angles theorem, if we have two angles cut by, or two lines cut by a transversal, and we have our two angles between those lines, they're going to be supplementary. They're going to add together to be 180. So these here do add together to be 180 because they're between parallel lines. And that will be true of any trapezoid. So let's look at this one here. So they gave us an angle A is 42. We want to find the measures of angles B, C, and D. Which one do we know for sure? Exactly, it's also a base angle, so this one has to be 42. How many other angles do we really need to find? One, because if I find the measure of angle B or C, we have the other. How can we find B or C? Because these two angles do add together to be 180. Or we have that all four angles add together to be 360. So we could say that x plus 42 is equal to 180. Subtract 42 from both sides. X is equal to 138, which means angle C has to be 138. Questions on this so far? And again, if we want to check it to make sure that this does work, we could do 138 plus 138 plus 42 plus 42. You can do that in a calculator. You can plug it in and see, does this give us 360? Because the sum of the interior angles of any four-sided figure has to be 360. Well, that there is 10, 20, 4, 8, 9, 10. So those 36. 1, 2, 3. We do add together to be 360, so we did get the correct answers. Any questions on this here? Questions on anything we've done so far? We ready for the next part? Find all the missing angles. Find all the possible missing angles. So, which angles do we know for sure? S is 65, yes? Is angle P 65? Is it an isosceles trapezoid? No, it's trapezoid because all the ones we're dealing with today are trapezoids. But we can't say that SR and PQ are congruent. So since they're not congruent, it means it's not an isosceles trapezoid, which means we can't say the base angles are congruent. So the only angle we can find is S and R, because the consecutive angles, the non-base angles, so the top two angles are base angles, the bottom two angles are base angles with each other. So the non-base angles are going to add together to be 180. So if we want to find that, really, these two angles add together to be 180. So we could say x plus 65 is equal to 180, or really just subtract 65 from 180, which is and 15 degrees. Any questions on this so far? What is the only thing we can say about angles P and Q? That they make 180. Yeah. These two angles here are going to add together to be 180 degrees. Now there's way too many ways to add two numbers together to get 180, but we can't really tell what they are. Yeah.
Can I have your attention? High school cheer practice is canceled for today. High school cheer practice is canceled for today. Thank you.
All right. Let's look at this one here. So we want to find all possible missing angles. We know that angle C is 60 degrees. Are there any other angles that we can tell by just looking at this? Okay. How can we find the measure of angle D?
180
Yes. All right, so this is 120. Yeah, E is 120 and F is 60. Because CD and FE are congruent, and we're talking about trapezoids, it's isosceles. It's an isosceles trapezoid. So the base angles are congruent. So that means the measure of angle F is 60, and the measure of angle E is 120. Any questions on this here? No questions, Brooklyn? Do we need to see another example of one of these here? So for this here, we can find all of them. So this here would be 70 because the legs are congruent. And if we subtract 70 from 180, if the measure of angle HEF, the whole angle, is 70 degrees, and the measure of FGH is 110 degrees, is trapezoid EFGH isosceles? Can we say this is an isosceles trapezoid? If it is, or if it is not, what do we know about angles E and H? They equal 180. So I can subtract 70 from 180 and get what? The base angles are now the same. If the base angles are congruent, then we can say it is. Yes. The base angles are congruent. Yes, the base angles are congruent, so that means it is an isosceles trapezoid. Questions on this one here? If EG and FH are congruent, can we say it's isosceles? Yes. Because of our diagonals theorem at the beginning, if the diagonals of a trapezoid are congruent, then it has to be isosceles. Questions on this here? Because we can, trying to look at, see the best way to explain it, because we can use it based off of triangles. Because what we're wanting to show that these two lengths here are congruent. And we know that these two here are. So those are congruent. Share, yeah. what we can do is look at this triangle here, and let's get another color, purple. And this triangle here. We can break it up to those two triangles. Now the reason I do that, for one, is that in both of these triangles, let's actually grab, no, not what I wanted. Well, here, and the one in purple. So these are the two triangles from that trapezoid. And if we put the letters in, we have E, now it wants to be E, G, H. And this is H, G, F. Now, these two are already congruent because it's the same line, yes? Now we know that these two are congruent because they are the diagonals. I need one other part. There's H and G. Nope. Where it is. Alternate. Yep. Now with the parallel sides, those angles and those angles are going to be congruent. Let's see the one other piece, because this is the side we're wanting to show is congruent. Angle. So we're just missing one on the last piece. Yes, because it's going to be involving these angles being congruent because of the parallel lines and working it through. So the third one is. So we can use our triangle congruency statements to get there. Essentially what it's doing. And it's, yeah. Any other questions on this here? Because that wasn't a full explanation, because it would take a little bit to get to the angles being congruent. Now, these here, because again, we're getting right to the end, are not too bad. Because if this here is an isosceles trapezoid, what do we know about the two diagonals? Okay, they're congruent. So if KM's 22, JL has to be 22, because they are the exact same length. If DF is 8.7, EG has to be what? Yep. I mean, we can make it quote unquote harder, but all we would be doing, instead of saying 8.7, we'd make it 2x plus 3. We can say EG is x minus 7. Solve for the value of x, plug it back in. Is that really making it any harder? No, it's just more steps. This here is the last thing we're covering in this here, and it is the midsegment. The midsegment of a trapezoid theorem. The midsegment of a trapezoid is parallel to each base. So the midsegment, when we draw it, connect the two midpoints of the legs, it's going to be parallel to each base. And the midsegment itself, its length is equal to half the lengths of the other two sides. It's equal to half the length of AB plus CD. Questions on this so far? That seems like an odd way to set this up, but it actually is true. If we move that over just a little bit, take this here. I'm going to use keys, Control A, group. So what I'm doing here is kind of giving you guys an example of this here. So we have the shape, yes? If we flip it, we actually just make a parallelogram. And these three lengths are going to be the same. So it ends up adding together. Now, to get that there. Now, for us here, it's not too bad. Because the overall formula of the mid-segment, which in this case is MN, is equal to half of the top plus bottom. And for us here, they already gave us the top length. The measure of the top is what? Plus the measure of the bottom. All those are just numbers. We can plug it in and solve. So 12 plus 28 is, so we have to take half of 40, which is, so MN, the mid-segment is 20. Half, or multiplying it by half works too. Yeah, because if we multiply it by half, we always multiply with the top, so it'd be 40 over 2, which is 20. Questions on this here? We're ready for the next part. So here we're still wanting to find the mid-segment, and they gave us the top and bottom. So it's half, the mid-segment is equal to half of the top measure, which is 13.5, plus the bottom segment, which is 18.9. And the mid-segment's value will always be between these two lengths because it's in the middle. So the mid-segment, MN, is equal to half. So we can say 13.5 plus 18.9. Yes. 32.4. So we can divide this by 2, or we can multiply it by 1/2. Either way works, which would be 116.2. Questions on this here? We ready for the next one? So here, if we wanted to find the mid-segment, AB would equal what? Half of the top, which is, plus the bottom, which is, so we can say 9 plus 13 is, and half of 22. Any questions on this here? I think we feel comfortable with these, yes? Were we given the top and bottom for this one here? Top and the mid-segment. Well, the mid-segment, 19, is equal to what? Half of the top plus the bottom.
So you would times the mid-segment by 2.
Yes. So we want to get x by itself. That 1/2 is really making a mess of things, yes? So what is 2 times 1/2? What's 2 times 1/2? 1, yes? 2 times 1/2 is 1. These will, and what I do to one side, I have to do to the other. 2 times 19 is 38. Now the half's gone. Do we need the parentheses anymore? So it is now 13 plus x. We multiplied it by that 1/2 to get rid of, or multiplied it by 2 to get rid of the 1/2 and those parentheses. So x is and that's it. Now again, whenever we do these, the mid-segment will always be in the middle. So since we were given the middle and the top, the bottom section had to be bigger than 19 because we need it so that the mid-segment's still in the middle. Let's look at this one here. So the mid-segment is what? It's going to be equal to 1/2 of x plus 4.4. How we arrange that really doesn't matter. X plus 4.4 or 4.4 plus x are the exact same thing. So what can we do first? Multiply both sides by 2. Because that's what we're going to do first for each of these to get rid of that 1/2. Because 2 times 1/2 will simplify to 1, leaving us with x plus 4.4. Now 5.5 times 2. And then we will need 2 minus 4.4 from both sides. And we get that x is questions on any of this here? I think we have one more, yes? What's the difference between 4.4 and 5.5? What is the difference between these two here? What's the difference between here? Because it's going to be in the middle, the exact middle. So the distance from here to here should be the same as the distance from So this one here is a little bit different, and it is the last one that we're going to look at. Now we know that what? The mid-segment, which is equal to 1/2 of the top, which is plus the bottom, which is we're still going to work this the same way. Now, the first thing we can do is combine like terms inside the parentheses. 2x plus 11x is 13x. 4 plus 2 is? Now, we could multiply the 1/2 through. Is 13 divisible by 2? Now, 13 times 1/2 is not going to be a nice number. So we can? Because we can still multiply both sides by 2. Because we're just scaling it. It's making everything bigger, everything smaller. It's not changing the answer, it's just changing how it looks. Now, here, these cancel, leaving us with 13x plus 6. 2 times 29. What can we do next? Minus 6 from both sides, yes. Which will tell us that 52 is equal to, and last but not least, by 13. Which tells us that x is equal to, now we will need to plug it back in to find the lengths. So here we'd have 2 times 4 plus 4. And 2 times 4 is? Plus 4 is? So the length of yx is Now for the bottom section, we can do 11 times 4, 2, yes. 44 plus 2 is 46. Well, if we wanted to, so the distance from 12 to 29 is, and 29 to 46 is, because again, mid-segment is going to be in the middle. That is it.